So in this video I'm going to look at synthetic division and how we can use synthetic division to evaluate functions. So let's look first at the first problem here. Is find the quotient if f of x is divided by x minus 3. So we have a polynomial function here. So just to remind you, I'm going to look at it, do the long division here. I kind of have it set up just to save some time and shorten the video a little bit. So remember, when you use long division, the dividend, which is this polynomial here, has to be in descending power. So we have all the terms in descending power: x to the fourth minus 3x to the third plus 7x squared minus 5x plus 3. And we're going to divide. Okay. So the way it works again, the divisor has to be in descending powers also, so we have x minus 3. So we divide the x into the x to the fourth. That should give me x to the third. Okay. And then I multiply the x to the third times the divisor, which is x minus 3. So that gives me, as you see down here, x to the fourth, and then x to the third times minus 3 gives me minus 3 x to the third. And then here, just like it is with numbers, we subtract. So here, we're going to subtract. So this becomes a minus x to the fourth because we're subtracting, and x to the fourth cancel. This minus becomes a plus because the subtraction makes it positive. So these cancel out. So then over here, then I'm just subtracting 0 from these other terms, so I just bring those down. 7x squared minus 5x plus 3. And then I continue with the procedure. Okay, so now this becomes my new dividend, and I just keep repeating this procedure until the remainder has degree smaller than the divisor. The divisor has degree 1. Here my remainder, if I were to stop here, would be 7x to the second minus 5x plus 3. So I continue with division. The x against divides the 7x squared. That gives me a plus 7x. And then now this partial quotient, if you want, multiplies the divisor, the x minus 3. So 7x times x is 7x squared. I bring it down below the first term here. 7x times the minus 3 is minus 21x. Okay, and then here we subtract again. So 7x squared, subtract 7x squared, that gives me 0. Minus 5x, subtract minus 21x. The subtraction makes this minus a plus. So that becomes 21x minus 5x is 16x. And then here, the next term, as subtracting 0, 0 from 3 is 3, so that stays plus 3. Okay, now the remainder, if I were to stop here, the remainder would be 16x plus 3. But this has a degree of 1, and the divisor has a degree of 1. I have to continue this procedure until the remainder has a degree smaller than the divisor, or until I get a remainder of 0. So I continue. X into 16x, the x's cancel out, and I get 16. Okay, so far then I've got x to the third plus 7x plus 16. Okay, let me scroll down a little bit more here. So now the 16 multiplies the x minus 3. So that becomes 16x, or 16 times x gives me 16x, there it is. And then the 16 times the minus 3 is the minus 48, and then I subtract here again. So this becomes, and 16x minus 16x cancels to 0. And then 3 subtract minus 48, that becomes a plus 48, so 48 and 3 is 51. Okay, so this should be 51 here. This should be 51. Okay. So the quotient for this one is x to the third plus 7x plus 16. The quotient is x to the third plus 7x plus 16. The remainder is 51. Okay. Point out again that when you do the long division, the terms of the dividend must be in descending powers. And it's so really convenient if you have any missing terms to put a 0. So had there been no minus 3x to the third here, I would have put a 0 right here. Or had there been no 7x squared here, I would have put a 0 there. The divisor, again, you want it in descending powers. The highest degree term first, x, and then in this case the constant. Now, we're going to do the same problem using synthetic division. Now with the synthetic division, we simply use the coefficients of the dividend. So in this case, this would be a 1, a minus 3, a 7, a minus 5, and a 3. Okay? And then synthetic division basically works best when you're dividing by a binomial. And it has to be first degree binomial. Okay, so if you're dividing by something that is, say, second degree or higher, then synthetic division is not going to work. Okay, you're going to have to use long division. Synthetic division basically works if you're dividing by a first degree binomial, say of the form x minus k. Okay, x minus k. So let me clear this. And let's look at the synthetic division. So here's the way it works, the synthetic division. Let me correct this one here. 51. Okay. So here's the way it works for the synthetic division. Same problem. We put the coefficients of in this case the polynomial function. Again, if there's any missing terms, so again, if there had been no cubic term here, this minus 3 would have been 0. Okay. In this case, we didn't have any, so we have the coefficients, and we put a little box right here. So again, if you're dividing by something of the form, if the binomial again is first degree of the form x minus k, then what you put right here in this little box is going to be k. Okay, so if you're dividing by x minus 3, which is what we're doing now, you would put a 3 right here. If you're dividing by x plus 3, in order to have this in the form x minus k, this would be written as x minus a minus 3. So the k in that case would be negative 3. So this 3 would be a negative in that case. Okay. So the way it works then is I leave some space here, draw my line, and then whatever coefficient you have here, you put it below the line. That's 1. And then it just works this way. 3 times 1 is 3. And then I add these. Negative 3 and 3 is 0. Then continue the multiplication. 3 times 0 is 0. Bring it over to the next position right here. 7 and 0 is 7. 3 times 7 is 21. Bring it over to the next one. I add negative 5 and 21 is 16. And then 3 times 16 is 48. Bring it over to the next position. And then I add 3 and 48 is 51, which is what I got over here when I made the correction. Okay, and so when you divide a polynomial by first degree, everything reduces by 1. So this 1 here corresponds to the first term of the dividend, which had an x to the fourth. So down here in the quotient, these represent the coefficients for the quotient. So this would be 1x to the third. And then the next one would be, if we go in descending powers, would be an x squared. Coefficient means, okay, it's 0x squared, so I just leave it out. And then the next one is 7, and the variable there would be x. And then we go down again, reduce the part by 1, I get x to the 0. That's just gives me 1, so this gives me 16. Okay, get the same answer. X to the third plus 7x plus 16 is the quotient, and this 51 right here is the remainder. Okay, now how does this apply to evaluating functions? Well, let's look at the next one. Clear this. And here's what we have. This one states, evaluate the function in problem 1 at x equal 3. Okay, so that simply means I could do this several ways. I could come back to the function f of 3, and where I have an x, I would put it 3. So this would be 3x to the 4th minus 3 times x to the 3rd. Or 3 to the 3rd, if I put the x value there. Plus 7, 3 to the 2nd, minus 5 times 3, plus 3. And do that calculation. If I do it manually, you're going to get 51. Okay, you can check it out. You get 51. You can do it in a calculator also. I have some videos on the graphing calculator. We can do these types of problems on the calculator, but this is basic math, so you should be able to do it manually. So if you're evaluating a function, this is basically saying, and this has to do with the remainder theorem, which you study in college algebra. If you're evaluating a function f at some number k, you want f of k. So that could be f of 3, f of negative 3, f of whatever. If you divide that function by x minus whatever the k is, using either this long division or using the synthetic division, whatever you get for your remainder, which in this case is going to be 51, that's going to be the value of the function at that particular number. Okay, so what we're saying then, in this situation, we're saying that f of 3 is equal to 51. Okay. So this is just a short video on synthetic division and how you can use it to evaluate functions. And I hope this will help you in your study of mathematics, and we'll check you out in the next video.